So here we want to make sure we can state the domain of this. Well, the inside restriction, it looks like there's no restriction on the inside. Okay, so the square x squared plus 5 is always going to be positive, so there's no domain restriction there. To find out the outside domain restriction, it's much easier to make it equal to the square root first. So I'm going to add x to both sides, and this makes it easier to see the the outside restriction. So we know that x must be greater than or equal to 5. Okay, so there's our outside restriction. Once we've established that, we can solve. We're going to undo the square root with this square both sides. Okay, and then I'm going to end up with x squared plus 5 is equal to x squared minus 10x plus 25. X squareds cancel, make it equal to z. Well, since it's not a quadratic anymore, I'm going to move the 10x to this side, so plus 10x on both sides, subtract 5 from both sides, and I end up with x is equal to positive 2. Okay, so based on our restriction though, it doesn't look like it works. Okay, so we should check. Okay, I'm just going to check because again I'm not super confident with I'm going to test this, and because I'm not super confident with my domain restrictions. So if I test x equals 2, testing x equals 2, I get square root of 2 squared plus 5 minus 2 equals negative 5. Okay, so I get square root of 9 minus 2 equals negative 5. Well, no, that's not true. 3 minus 2 is not equal to negative 5. Okay, so this is definitely extraneous. Okay, so we can get that from our domain restriction, but we can also get it from actually testing the value. And that testing is actually the most reliable. Okay, sometimes it can be a bit tedious, so if we're good with our domain restrictions, that's actually much better. So what would this graph look like though? Well, I wouldn't really expect you to know what this graph looks like, but if I were to graph this, I would graph y equals square root x squared plus 5. That's my y1. My y2 is going to be x minus 5. So plugging this into my graphing tool, I'm going to get x squared plus 5, and then x minus 5. My graphing tool shows me that the shape here is actually called a hyperbola, and then I also get a line that looks like this. Okay, and it looks like those lines, since this is kind of curving towards that, it looks like these are asymptotes, or sorry, these end up being kind of parallel lines, so there's no solution. There's no intersection. Okay. Now, I wouldn't really expect you to know what that graph looks like. However, I do want to encourage you to start looking at the graphs of these equations and trying to understand why we get these extraneous solutions based on the shapes of things, because the shapes of things tell us a lot about the math of the system that we're dealing with.